On number 22, it says, what is the value of x in the given equation? So basically, we need to bring that whole equation down and start working with it one piece at a time. We have 27 raised to the x multiplied by 3 raised to the 5x minus 4 equals 1 over 9 to the x. Now, whenever you're solving a problem like this and you have exponents involved, you want to get everything into the same base if possible. So we're going to start with 27, and I'm just going to bring it over here to the side. 27 would be 3 times 9. 3 is prime, so we keep it. 9 can be further broken into 3 times 3, which is perfect because then that leaves me with a base of 3. So 27 can be written as 3 raised to how many of those do we have? We have 1, 2, 3 of them. So 3 raised to the third power. That's the number 27. But we still had 27 raised to the x. Then we have it multiplied by, there's that same base. I bet our bases are all going to be broken down into 3s. 3 raised to the 5x minus 4. Can't do much with that because it already has that 3 and that's prime. Now this 9 to the x, you got to be a little careful on this. That 9 can be broken down into 3 times 3, which is perfect. So we're going to have that as 1 over 3 squared, so that represents that 9 raised to the x. So there's that 9 to the x. Let's keep working. Now, whenever you have a parentheses involved, there's distributive property involved. So it's going to be 3 times x, and since that's the only thing, that's going to give me the base of 3, so that base raised to the 3x. That's going to be multiplied times 3 to the 5x minus 4. And then that's going to equal what we have over here. This is going to be in the denominator 1 over 3 raised to the same properties over here, 2x. However, there's a little trick problem involved in here because that 3 is in the denominator. We need our bases all to be in the numerator. We can push this whole thing up to the top, but when you do, the exponent law says that this is going to become opposite in value. So that's going to actually be equal to 3 raised to the negative 2x. So anytime that you have that negative exponent, think about the reverse. We put it as 1 over 3 to the 2x. So you can go backwards and forwards. So here I have 3 raised to the negative 2x. Now we have everything in the same base. But we need to go ahead and clean up one more time on this side here. Whenever you have the same base and you're multiplying them together, you are supposed to add these exponents. So really that leaves me with 3 to the 3x plus 5x minus 4. And that's going to be equal to 3 to the negative 2x. Now we have just one base on the left of 3 and one base on the right of 3. When you have the same bases, you can drop the bases and set those exponents equal to each other. So now we just have one big equation to solve here. 3x plus 5x is 8x minus 4 equals negative 2x. Now since this is the only thing over here, I'm going to go ahead and move the 8x. So I'm going to subtract 8x from both sides. Those will cancel. Negative 4 is going to equal, on this side, negative 2x minus 8x would be negative 10x. So I'm going to bring that over here, and while I'm at it, I'm going to go ahead and flip this because I know some of you guys always like to have your variable on the left. So there's that negative 10x, it equals negative 4. Now I'm going to get rid of this negative 10. Since it's negative 10 times x, we're going to divide both sides by negative 10. Those are going to cancel. X is going to equal, and negative over a negative is a positive, and then 4/10 can be simplified because 2 goes into both of them. 2 goes into 4 2 times, and it goes into 10 5 times. So we have x is 2/5, which is our answer choice B in this problem.